If wood takes decades to recover, bamboo only needs a few years to return to the production line. That speed explains why bamboo is becoming the king of new materials in an era of plastic reduction and deforestation reduction. The global bamboo market has reached a scale of tens of billions of dollars, with applications ranging from food, single-use products, paper, furniture, and construction. But the true value of bamboo only begins after it is harvested at the right age, processed properly, and taken through drying, splitting, planing, pressing, or grinding stages. In this video, let's join Factron Process to see how bamboo is taken out of the forest, enters the factory, and becomes part of the green materials revolution. In 2025, the global bamboo market is estimated at around $70.1 billion USD, with bamboo covering about 35 million hectares across Asia, Africa, and the Americas. What makes this plant special is its incredible regeneration speed. After only 3 to 5 years, bamboo can be ready for the next harvest, much faster than traditional wood. With its rapid regeneration and massive market scale, bamboo is no longer just a traditional raw material. It has broken through to become a strategic material of the new century. Yet to turn that raw potential into billions of dollars in revenue, everything must begin from one core link: the high-tech harvesting and processing system, where a local natural resource is transformed into a super material capable of replacing both wood and plastic. The journey of bamboo begins in hilly and mountainous areas, where the land is steep, paths are narrow, and large machinery can hardly reach. In many bamboo-growing regions across Asia and Latin America, farmers still rely on traditional experience to manage bamboo forests. They understand which culms are still young, which ones are mature enough, and which bamboo clumps need to be kept so they can continue regenerating. What makes bamboo cultivation different is its extremely fast growth rate. According to Guinness World Records, some bamboo species can grow up to 91 centimeters in 24 hours, almost the height of a small child in just one day. However, for the culm to reach the hardness and quality needed for production, growers usually have to wait about 3 to 5 years. After this stage, bamboo can be harvested periodically for many years, because the underground rhizome system remains alive and continues to produce new shoots after each cutting. The special feature of bamboo lies in its underground root system. After each harvest, the rhizomes remain in the soil and continue pushing up new shoots. This means growers do not have to start over after every crop. In areas prone to erosion or difficult to cultivate, bamboo becomes an especially effective choice. It generates income, holds the soil, and helps green areas where many other commercial crops struggle to grow steadily. Harvesting bamboo is not about cutting as much as possible. Farmers must select the right mature culms, usually based on color, hardness, diameter, and position within the clump. Culms that are too young contain a lot of water, shrink easily, and are less durable. Culms that are too old risk cracking, becoming brittle, and being difficult to process. Because of that, every cut is a decision about raw material quality. A machete or handsaw is used to cut close to the base, but the cut must be clean so it does not damage the rhizome underneath. This selective harvesting method allows the bamboo clump to keep living, keep producing new shoots, and avoid overexploitation. After being cut, workers trim off the branches, pull the culms out of the clump, and bundle them into long groups. In steep mountain areas, transporting bamboo can be just as difficult as harvesting it. Bamboo is carried on shoulders, pulled by ropes, transported by pack animals, or moved downhill using temporary pulley systems before being loaded onto trucks. If the culms are hit hard, split lengthwise, or crushed at the nodes, their usable value drops significantly. Therefore, from the moment bamboo leaves the clump until it reaches the preliminary processing station, the entire process must preserve the straightness, length, and natural structure of the culm. When bamboo is brought to the preliminary processing station, each culm is inspected and sorted before going deeper into the production line. Workers or measuring machines evaluate diameter, wall thickness, straightness, length, color, and the level of cracking or damage. Straight, strong culms with fewer defects are usually prioritized for higher value products, such as bamboo flooring, pressed panels, furniture, or household items. After sorting, bamboo is sent to the preliminary cutting area. Here, automatic cutting machines or industrial bandsaws cut the culms into sections of different lengths, depending on the final product. Bamboo used to make chopsticks, straws, or toothbrushes is usually cut into shorter sections, while bamboo for plywood, furniture, or construction materials is kept longer to make the most of the fiber structure. During cutting, roller systems hold the culms in place to reduce vibration and ensure the cut surface is perpendicular to the culm axis. Curved, small, or defective sections are not discarded. They can be ground to make paper, fiber, bamboo charcoal, biomass pellets, or compost. From this stage, each bamboo culm has already been directed toward its own production journey, reducing material loss and improving the efficiency of later splitting, planing, pressing, or shaping stages. From the bamboo sections that have been sorted and cut to specification, the factory begins turning them into common consumer products such as chopsticks, straws, spoons, skewers, knives, forks, or toothbrushes. This product group has very high demand because the production process is fast, the raw material is easy to standardize, and it can replace part of the single-use plastic used in restaurants, cafes, and retail chains. For bamboo chopsticks, the culms are split into strips then sent through a blank forming machine. Here the machine cuts, turns, rounds the edges, and smooths each stick to create a uniform shape. In large production lines, many stages are continuously automated, from splitting strips and sizing to sharpening the ends and polishing. A well-coordinated line can produce hundreds of thousands of chopsticks in one shift. For bamboo straws, the factory selects small bamboo sections with naturally suitable diameters, then cuts them into pieces, clears the hollow core, smooths both ends, washes them, and dries them. Each straw still keeps its natural bamboo color and grain, so no two products are exactly alike. For spoons, skewers, and other eating utensils, bamboo blanks are cut to standard dimensions, then pressed, turned, or shaped with heated molds to achieve the desired design. After shaping, all products must go through finishing and hygiene treatment. The surface is sanded to remove splinters, polished to smooth sharp edges, and may be coated with a layer of vegetable oil to improve moisture resistance. Because this product group comes into direct contact with food, the factory must strictly control moisture, drying time, temperature, and ventilation. Products may be treated in thermal drying chambers with steam or with suitable anti-mold solutions to reduce bacteria and limit mold growth during storage. Finally, products that are bent, cracked, still have splinters, or have not reached the required dryness are removed before packaging. Finished products are packaged individually, in pairs or in sets, using paper, biodegradable bags, or vacuum packaging, depending on the export market. From one raw bamboo culm, the line has created products that are durable, safe for food contact, and carry a natural rustic beauty that industrial plastic can hardly provide. Not every part of bamboo is suitable for chopsticks, straws, or eating utensils. Small, short, curved, or difficult to process sections are sent to another production line where they continue to be used instead of being discarded. In the paper factory, bamboo is chipped, ground, cooked into cellulose pulp, and then washed. After that, the bamboo pulp is bleached, diluted, rolled thin, and dried into paper. Bamboo fiber has good length and toughness, making it suitable for toilet paper, tissues, writing paper, packaging, and many other consumer products. In China alone, bamboo pulp production capacity once reached about 2.4 million tons in 2017, showing that this is no longer a small-scale field. When managed sustainably, bamboo paper can help reduce pressure on traditional wood forests. While smaller parts are sent to the paper production line, straight, thick bamboo culms with beautiful fiber are prioritized for higher value products, pressed bamboo panels, furniture, and construction materials. In construction, bamboo has been used for centuries, from scaffolding, roofs, walls, temporary bridges, to lightweight building frames. Its hollow structure makes the culm light, while the fiber bundles running along its length provide remarkable tensile strength. But in modern production, bamboo is not only used in its whole culm form. It is brought into the factory, processed into strips, pressed into panels, and turned into flat materials that can replace wood in many applications. To produce pressed bamboo panels, bamboo strips that have been dried are planed flat, sorted by color, coated with adhesive, and arranged in multiple layers. These layers can be placed in the same direction or alternating directions to increase stability, limit warping, and make the most of the natural fiber structure. After that, the entire material block is placed into a hydraulic press under high pressure to form strong, flat, and uniform bamboo panels. Once the adhesive has cured and the bamboo panel reaches the required stability, the factory cuts it to size, sands the surface, treats it against moisture and insects, and checks its flatness. Finished products can be used for flooring, tabletops, cabinet doors, partitions, wall panels, ceilings, or interior decoration. From the original small bamboo strips, the production line creates a modern construction material that preserves the natural appearance of bamboo while fitting projects that aim to reduce their carbon footprint and increase sustainability. After large-scale industrial production lines, bamboo still has another path that is more handcrafted and personalized. Not every bamboo product requires pressing machines, grinding machines, or automated lines. In many small workshops, the artisan's hands are the most important tool for turning thin bamboo strips into products with their own aesthetic and cultural value. Thanks to the flexible shaping ability of bamboo fibers, artisans can weave baskets, trays, containers, lanterns, bamboo blinds, handbags, or interior decorative items. Bamboo weaving requires precision in every strip. The artisan must know how to choose strips that are flexible enough and even enough, then thread, tighten, and lock the weave so the product is both strong and able to retain the natural character of bamboo. A bamboo basket may look simple, but it can take many hours to complete, from forming the frame and weaving the body to reinforcing the rim and treating the surface. In many rural communities, small bamboo workshops create jobs for artisans, packers, material processors, and sample designers. The value of bamboo therefore lies not only in the material itself, but also in the local labor chain behind it. A small product such as a travel cutlery set, a woven basket, or a handcrafted bamboo tray can carry within it the techniques, culture, and livelihood of an entire community. From bamboo clumps growing on steep hillsides to the moving lines inside modern factories, we have followed the full journey of a material that looks simple at first glance, but carries enormous industrial value. A bamboo culm that once stood in the forest can be selected, cut, transported, sorted, split, dried, shaped, pressed, polished, or ground until it becomes something completely different. Some parts become chopsticks, straws, skewers, spoons, knives, forks, or toothbrushes, replacing part of the single-use plastic that appears every day in restaurants, cafes, and retail chains. Other sections are chipped and processed into cellulose pulp, then turned into toilet paper, tissues, writing paper, packaging, and many other paper products. The straighter and stronger culms can be transformed into pressed bamboo panels, flooring, furniture, wall panels, ceilings, and construction materials. And beyond the factory, thin bamboo strips can still enter small workshops, where artisans weave them into baskets, trays, lanterns, blinds, handbags, and decorative objects that carry the mark of human skill. What makes bamboo remarkable is not only how fast it grows, but how efficiently it can be used. Straight sections can become high-value materials. Smaller, curved, or imperfect parts can still enter paper production, fiber production, bamboo charcoal, biomass pellets, or compost. Even the thin strips left after cutting and shaping can continue their life in handcrafted products. Very little has to be wasted when the material is planned and processed properly. That is why bamboo is no longer seen only as a traditional rural material. It has become part of a larger shift in the way industries think about resources. Instead of depending only on slow-growing timber or disposable plastic, more producers are looking for materials that regenerate faster, create less waste, and can serve many different markets at once. Bamboo fits that role because it can move from the hillside to the factory, from the factory to the home, and from everyday objects to modern construction. Behind every bamboo product is a chain of decisions. Which culm to harvest, which section to keep long, which part to cut short, which strip to press, which fiber to grind, and which piece to place in the hands of an artisan. That chain is what turns a hollow green stem into a resource with real economic, practical, and cultural value. So the next time you see a pair of bamboo chopsticks, a paper product, a bamboo floor, or a woven basket, remember that it did not begin as a simple object. It began as part of a living clump, grew for years, passed through human hands and factory machines, and became one small example of how nature and industry can work together. If you found this journey interesting, don't forget to like, subscribe, and turn on notifications to continue joining Factron Process in the next industrial stories.